Good day, everyone. So today I'm here to discuss you all about physics. So let me first share you my screen. Physics. So what is physics? Physics is one of the most fundamental scientific disciplines, and its main goal is to understand how the universe behaves. It is also the simply it is also the study of matter, energy, and the interactions between them. Lastly, it is the natural science that studies matter, its motion, the behavior through space and time, and studies the related entities of energy and force. This topic is divided into 5 parts. We will tackling SI units, metric system conversion, English system conversion, significant figures, and solving significant figures. First, SI units. So, what is SI units? SI units is the standard measurement system used in science. It is composed of 7 base units, and from these units arise the derived one, which is the derivatives. Examples of SI units are MKS, CGS, and FPS. What do we measure? We measure we measures fundamental properties, or we call the base units, which are mass for weight, it is kilogram, length, meter, time to second, temperature to Kelvin. And the derived quantities or units are density, velocity, force, and etc. We're now moving into the next lesson. The next lesson is metric system conversion. What is a metric system conversion? It is a system of measurement that succeeded the decimalized system on the meter introduced in France in the 1790s. It is the historical development of this system culminated in the definition of the SI units, which we discussed a while ago. In, in using matrix conversion, prefixes are used to identify the multiples of 10. The base is 1, and deca is the multiple of 10 with a power of 1. Hecto, multiple of 10 with a power of 2. And kilo is a multiple of 10 with a power of 3. The small numbers are with the deci, which is multiple of 10 with a power of -1. Centi, a multiple of 10 with a power of -2, and milli, a multiple of 10 with a power of 3. So the table you see in the screen is the commonly used table in doing metric conversions. Here is one example of doing metric system conversions. Convert 37.2 millimeter to meter. It is 37.2 millimeter times 1 meter. So why meter is in the numerator? Because the value that we want, which is meter, will be on the numerator, and the value given, which is millimeter, will be in the denominator for us to cancel it out. So let us now cancel out the millimeter for the meter to remain. Cancel out millimeter and the final answer will be 0.0372 meter. In summary of converting metric to metric system is we use the multiple of tens and the table that I showed you a while ago, and we can move the decimal or we can use conversions to get the final answer. We are now moving to the next topic. The next topic is the English system conversion. So we here have the conversions for the length, which are 1 foot is to 12 inches, 1 yard is to 3 feet, 1 mile is to 5,280 feet. Example of this English to English conversion in length is convert 336 feet to yard. It is, we can write is by 336 feet times 1 yard divided by 3 feet. So we cancel out the feet. So the remaining is the yard. So the final answer is 142 yards. Next is the English to English conversion for weight. The given conversions are 1 pound is to 16 ounces. 1 ton is to 2,000 pounds. Example of this is convert 24,000 pounds to ton. We can write it by 24,000 pounds times 1 ton divided by 2,000 pounds. We can now cancel out the pounds. And the remaining value is ton. So the final answer to 24,000 pounds times 1 ton divided by 2,000 pounds is 12 tons. The one I discussed with you a while ago is the English to English conversion. Now, we move to the English to metric system conversion for length. The given conversions are 1 inch is to 2.54 centimeters or cm. 1 meter is to 3.28 feet. 1 mile is to 1.61 kilometers or km. And 1 yard is to 0.91 meters. There is also the additional conversions. Here are 1 meter is to 100 centimeters, 1 kilometer is to 1000 meter, 1 foot is to 12 inches, and 1 yard is to 3 feet. Example, convert 41 cm to inches. We can now write it by 41 cm times 1 inch divided by 2.54 cm. Cancel out the cm. And the final answer into 41 cm times 1 inch divided by 2.54 cm is 16.4 inches. We have another example. Convert 282 cm to meters. We can write it by 282 cm times 1 meter over 100 cm. We can also cancel out the cm. And the final answer for 262 cm times 1 meter divided by 100 cm is 2.82 meter. Next is the English to English system conversion for weight. Here are the given conversions. 1 ounce is to 28.3 grams. 1 pound is to 0.45 kilograms. And the additional conversions are 1 pound is to 12 ounces, 1 ton is to 2,000 pounds, and 1 kilogram is to 1,000 grams. Here are the examples. Convert 7 kilograms to pound. We can write it by 75 kilograms by times 1 pound divided by 0.45 kilograms. Cancel out the kilograms. And the final answer for 75 kilograms times 1 pound divided by 0.45 kilograms is 166.67 pounds. Another example is convert 49 ounces to pound. We can write it by 49 ounces times 1 pound divided by 12 ounces. Cancel out the ounces. And the final answer for 49 ounces times 1 pound divided by 12 ounces is 3.06 pounds. We're now moving on to the next topic. The next topic is significant figures or digits. So what is a significant figures or digits? It is the digits are reported in a measured quantity. It is also indicate the precision of the measuring instrument. Its calculation should not have more significant digits than the least number of the significant digits that are given. There are also rules in identifying significant figures. These are: rule number 1. All non-zero numbers are significant. Example here is 343. There are three significant figures. Number 2. All zeros between numbers are significant. Example is 209. 209. There is also three significant figures because, as said as the rule number 2, the zeros that are between the significant numbers are also counted. Rule number 3. If decimal is present, zeros to the left are not significant. Example here is 0.0045. It have two significant figures. It only have two significant figures because the leading zeros are not counted. Rule number 4. If decimal is present, zeros to the right are significant. Example for rule number 4 is 0.010. It also have two significant figures. And lastly, rule number 5. If there is no decimal present, zeros on the end are not significant. Example here is 67,900. It has only three significant figures because, as said as the rule number 2, trailing zeros in the end are not counted. Now, we are moving into the last topic. The last topic is solving significant figures or digits. Adding and subtracting significant figures. In addition and subtraction of significant figures, the only rule here is to round up your answer to the least precise measurement or the least number of places behind the decimal point. For example, adding 224.676 plus 2.528 and 3.95 leads to 30.154. The final answer here is 30.15 because because as said as the rule, 3.95 has the least number of places behind the decimal point. For multiplying and dividing significant figures. In multiplication and division of significant figures, the only rule here is to round it up to the least number of significant figures. For example, 4.57 times 6.2. It leads to the answer of 28.334. Since the least number of significant figures in the given is 6.2, so the final answer will be 28 significant figures. Yay! We're done! Thank you for listening and watching. Hope you learned something today. Let me just stop sharing my screen. Thank you for listening. I hope you learned something and have a great day. Enjoy!